We've now looked at, we've taken the optimistic approach and we've looked at this in the contrast here for intervening material as a main effect. And we have also looked at the main effect for, so we've looked at the main effect for intervening material and we've also looked at the main effect for repetition. This is fine. But really the thing that we're interested in is this interaction term. So we've looked at these main effects more so just to show you how to do them, and so if there is a time that you need to do them, you now know how. But the interaction is really what we're interested in. And so when we're doing these interactions by hand, we're looking for the biggest area of non-parallelism, or effectively, if I went back and I produced my margins plot, we're looking for the biggest difference between two groups. And what does data want to tell me? Oh, it wants to tell me that it did something. Excellent. So the biggest difference of non-parallelism, the biggest difference of differences, is between my intervening materials at 4 times repetition compared to 12 times. Because the distance between these dots here and here is really, really large. It's my largest, and this distance is my smallest. Now, if I was to reverse this and do it the other way, I would come to the exact same conclusion. So my biggest difference is between numbers and nonsense syllable pairs at 4 times repetition, and my smallest difference is between numbers and nonsense pairs for 12 times repetition. So regardless of which way I look at this graph, I'm still coming to the same conclusion that I want to compare this line to this line. So again, we're going to do this by hand. You don't have to. You can do it through Stata. My recommendation, particularly for this tutorial, is to do it by hand. So it gets a little bit complicated setting up the contrast, but once you set it up, it's actually easier to run than the main effects. So on my left-hand side, I have the means, and I've got my means for each of my variables averaged across the other. And then I've got my cell means as well. So you can use the tab stat table to get something like this, like we did a couple of weeks ago. I've just put it into Excel so that it's there for reference. And when you're doing this by hand, I recommend having it somewhere for reference that's close by. And then what I'm doing is I'm looking at the main effect means. So the in this case, the number of words recalled for 4 times repetition averaged across intervening material, for 8 averaged across intervening, for 12 averaged across intervening. So I'm looking at these upper means. But I'm also looking at numbers and nonsense pairs averaged across repetition as well. So I'm actually ignoring these. So for better or worse, I could just get rid of these if I wanted to. So let's just make them white for now. And what I want to do is go, okay, so if I could run one contrast between numbers and nonsense, what would it be? And it would be comparing numbers to nonsense. There's only 2 groups. There's only one contrast I could run. And so then I would assign a 1 to numbers and a -1 to nonsense intervening material. And again, the only reason why I'm assigning a -1 here is because it's the smaller number. It doesn't have any effect on the results. It's just an aesthetics thing. And then I want the biggest difference here because I want, if I can only run one contrast, I want to give myself the best chance, right? The best chance of finding a difference. So I'd be comparing 4 and 12. So just by looking at these, I've already come to the same conclusion. I want to compare numbers and nonsense between 4 and 12. This is the same conclusion we came through by looking at the graphs. So I assign a -1 to 4 and a 1 to 12. I could do it the other way around, but 4 has the smaller mean, so I prefer to put -1s there. Now, this is where things get tricky. I need to figure out what my contrast weights are going to be for each of my cells, because in an interaction contrast, I'm actually using every single cell mean. I'm not using the averaged means. So, to get to these, I actually cross-multiply the 2 means that make it up. Sorry, the 2 weights that are comprised of that group. So this first group, this first cell represents those who had 4 times repetition and numbers for intervening material. So I multiply their weights together, 1 times minus 1. And 1 times minus 1 gives me minus 1. For 8 times repetition, number intervening material, it's 0 and 1. 1 times 0 is 0. For 4 times repetition, it's going to be 1 and 1, and this gives me 1. 1 times 1 is 1. And then I do the same thing for nonsense. Negative 1 and negative 1 is 1. Negative 1 times 0 is 0. Negative 1 times 1 is negative 1. And these are now my contrast weights. So now I need to go and get my cell means back. So now that we've come up with our weights, just like we did before, the next step is to calculate a contrast value. The formula hasn't changed. It's just longer. The contrast value is weight 1 times mean 1, weight 2 times mean 2, weight 3 times mean 3, weight 4 times mean 4, weight 5 times mean 5, and weight 6 times mean 6, because we have 6 cells. So, weight 1 times mean 1, negative 1 times 12. Negative 1, 12. Weight 2 times mean 2, 0 times 13.5, and so on and so forth. 1 and 15, 1 and 5.83, 0 and 10, minus 1 and 13.67. If I multiply out those ones by their means, I get 15 positive, plus 5.83, minus 12, minus 13.67. This boils down to 20.83 positive, minus 25.67. So as I was saying before, contrasts always have 1 degree of freedom because they always have 1 positive minus 1 negative. And that's what we get here. We've got 1 positive number minus 1 negative number. And that gives me a contrast weight of negative 4.84. So even though there are 6 means going into this, 4 of which have values, non-zero values, I still only have a negative and a positive number at the end of the day. And that's why contrasts always have 1 degree of freedom. So once I've calculated this, I can calculate the sums of squares. Now the sums of squares formula is exactly the same as before, except I don't have an A term. I don't have an A term here because all cells are accounted for. So otherwise it's exactly the same. 6 and then in brackets 4.84 squared brackets, and then underneath I've just got each of my weights squared out. I squared my 4.84, it gives me 23.4356. I multiply 6 by 23, it gives me 140 and a bit. I then multiply out my bottom and I get a bunch of 1s. I get 4 1s. I add them together and I get 4. 140 and a bit divided by 4 gives me 35 and a bit. I then calculate my F statistic, and so to do this, all I'm doing is taking my sums of squares of 35 and a bit, putting it in the top, and then using the same mean sums of squares error that I used from my main effects model, so 2.92. That gives me an obtained F of 12.03. Now I need to compare this to a Chef AF. Now, this is an interesting point. The Chef AF that I'm going to be using needs to be my critical F times the degrees of freedom for the IV. Now I know the degrees of freedom for my interaction is 2, and there's 2 ways I know this. First of all, the ANOVA tells me that the interaction's degrees of freedom are 2. And second of all, I know what the degrees of freedom for my IVs are. I can calculate it by hand if I had to. So the degrees of freedom between, for numbers of intervening material and my interaction are the same. They're both 2 in this case. And the residual is still 30. So if I looked up an F and an F table for my critical F, it's still just going to be 2 and 30. It's still going to give me the same value. So what this means is that the critical F for my Chef AF, so my critical Chef AF for my interaction, is actually just 6.64. It's the same as my main effects critical Chef AF. .03 is certainly larger than 6.64, and so what this means is that my interaction is significant. And so the way that I interpret this is I say, well, there is a greater difference in the number of syllable pairs remembered between 4 times and 8 and 12 times repetition, depending on the type of material presented, specifically where that difference is greatest at 4 times. I could even take it one step further by saying that you remember more syllable pairs at 4 times repetition if you had numbers intervening material compared to nonsense. So the way that we would formally conclude on this would be, in the population, whereas recall is substantially impaired, so up here, recall is substantially impaired when the intervening material is nonsense syllables compared to numbers, when the list is repeated 4 times. Recall is only slightly impaired when the intervening material is nonsense syllables compared to numbers when the list is repeated 12 times. Okay. I hope that gives you guys an overview of doing contrast testing by hand. I know it is really complicated, or at least it looks really complicated. My recommendation is to go away and do it by hand a few times. Once you've done it a few times, you go, oh, actually, this is really easy. It's just when you first see it, it looks really scary. So give it a go, have a bit of practice, and see how you go. All right, thank you guys.